You've rolled past hundreds of tanker trucks on the highway, probably thousands, and never once stopped to ask why they look the way they do. Why is the tank round? Why not a rectangle? Rectangles fit on shelves. Rectangles pack neatly into warehouses. Every other truck on the road hauls a rectangular box and nobody questions it. Why not a cube? A cube fits more stuff into the same amount of material. Why does every single tanker, every country, every company, every decade land on the exact same shape? And why does the answer also explain the scuba tank strapped to a diver's back? The fire extinguisher bolted to your office wall, the propane cylinder on your backyard grill, and the AA battery inside the TV remote you touched this morning. Why round tanks work better? A tanker truck is at its most basic. A container with wheels. That sounds unremarkable. But here's what's actually happening every time one of those silver cylinders passes you at highway speed. It's hauling up to 11,000 gallons of liquid at 70 miles per hour. 1 gallon of diesel weighs roughly 7 pounds. Run that math and you've got around 77,000 pounds of liquid that is very much alive inside that shell, surging, shifting, pushing with every turn, every lane change, every hard stop. That's the combined weight of roughly 25 adult elephants, all moving independently inside a metal skin, doing 70 on the freeway. That liquid is trying to tip the truck over. The shape of the tank is the only thing answering back, and round wins every single time. But here's the part that should make you feel a little tricked. Most people assume the tank is round because round holds more that it's a volume decision. It's not. A rectangular tank actually fits more liquid for the same amount of metal. Rectangular walls are easier to weld, easier to mount on a frame, easier to stack in a yard. If maximum capacity were the goal, engineers would have made that switch a long time ago. They didn't, and that refusal is the tell. The shape was never about holding more, it was about surviving the act of holding anything at all. So round isn't about capacity, it's about survival. But here's what that still doesn't explain: what happens when engineers ignore this. And what did it actually cost before anyone listened? That answer is coming up right now. Why not square tanks? When liquid presses against a wall, it pushes in every direction simultaneously outward, sideways into every surface it touches. Put that pressure inside a box and it doesn't spread evenly. It stacks up hardest at the edges and corners, the exact spots where two flat surfaces meet at an angle. Those junctions carry stress that the flat middle sections never see. Give it enough load or enough time, and that's precisely where metal cracks and seams split. A curved wall changes the equation entirely. Pressure arrives at the curve and gets redirected smoothly across the entire surface, distributing the load equally across every inch, with no corner to concentrate on and no weak point to find. Because that load gets distributed so evenly, a round tank actually needs less metal to safely hold the same pressure. Stronger than a square tank and cheaper to build. Same shape, two advantages from one decision. But pressure is only half the problem. There's a second force that the round shape is solving, and this one is the force that actually rolls trucks. How liquid pressure works? When a tanker brakes hard, the liquid inside doesn't stop with the truck. Physics won't allow it. In a rectangular tank, that entire mass of moving liquid arrives at the flat front wall at the exact same instant, like a wave hitting a seawall. All at once, full force, no warning. That sudden impact fights the brakes, throws weight forward, and on a curve it can tip the whole rig onto its side. In a cylinder, the curved wall catches that surge and redirects it. The liquid climbs the curve and eases back down gradually, the way water settles when you tilt a bowl and slowly bring it back level, spreading the energy out over time instead of delivering it as a single brutal hit. The round shape is a built-in shock absorber for liquid momentum doing work that no driver and no brake system can replicate on its own. This is also why modern tankers have internal dividers called baffles partial walls that run across the inside of the tank. Baffles break the liquid into smaller sections, cutting down how much fluid can build momentum in any one direction. Why cleaning square tanks fails? Here's one more reason that never makes it into the physics explanation, and it's the most practical one of all. Many tankers carry food-grade liquids, milk juice, cooking oil. When the truck reaches its destination, you need the tank completely empty. A flat-bottomed rectangular tank leaves a film of liquid across the entire floor, impossible to drain fully and even harder to clean. A cylinder drains itself. The liquid follows the curve to the lowest point, exactly where the outlet valve sits, and gravity does the rest. The cleaning problem is worse than it sounds. Corners are where residue hides. In a milk tanker, a thin layer of liquid left in a sharp corner overnight becomes a bacterial colony by morning, spoiling 5,000 gallons of fresh milk because a square tank couldn't be properly sanitized is not a hypothetical. It's exactly the kind of outcome that drove the design decision in the first place. A cylinder has no corners. One smooth, continuous surface, fully reachable, fully washable. How history-proved round works. This shape is not new. It wasn't invented for trucks or for the industrial age. Long before tanker trucks existed, people were moving liquids in wooden barrels round for the exact same reason. Curved staves spread pressure evenly so the barrel holds together under the weight of wine water oil. Ancient Romans used cylindrical barrels to supply wine across the empire. Sailors relied on them for drinking water on ocean voyages that lasted months in open seas. The barrel is likely humanity's first real pressure vessel, and it was already proven thousands of years before anyone could explain the physics behind it. Then came the Industrial Revolution. Early engineers built rectangular steam boilers because flat walls seemed simpler and cheaper. Those boilers kept exploding, always at the corners, always at the edges, always exactly where pressure concentrated. After enough failures and enough deaths, engineers switched to cylindrical boilers. The explosions stopped. By the 1860s, when the American oil industry scaled up fast in the Pennsylvania fields, that lesson was already burned into engineering memory. The first tank wagons built to move crude oil were cylindrical from day one. The tanker rolling past you on the highway right now is a direct descendant of those Pennsylvania wagons, built on knowledge that earlier engineers paid for with their lives. And you have been living inside this same logic your entire life without once connecting the dots. Where else around tanks appear? That beer keg at the party last weekend round because it holds liquid under CO2 pressure, and a flat-walled keg would split at the seams. That scuba tank a perfect cylinder because it holds compressed air at up to 3,000 pounds per square inch, and no corner could survive that for long. The fire extinguisher on your wall, extremely high pressure zero margin for a weak point cylinder every time. Your propane tank round because propane stored under pressure would start failing at the edges of a rectangular container after just a few heat cycles. The AA battery you touched this morning cylindrical because the chemical reaction inside generates outward pressure as it discharges, and the round shell absorbs that expansion evenly. The airplane you last flew in its fuselage is round in cross-section because pressurized cabin air pushes outward against thin air at altitude, and that pressure difference across thousands of flights would tear any flat-walled structure apart. Everywhere you look, the same equation keeps arriving at the same answer. What round tanks sacrifice? There is one honest trade-off, and it's real. A round tank sitting on a flat rectangular truck frame leaves dead space along both sides volume that a rectangular box would use and a cylinder never can. Engineers accepted that loss. Structural integrity and slosh control were worth more than the extra gallons. Some chemical tankers try to recover that space by nesting multiple smaller cylinders inside one outer shell, letting the truck carry different liquids in separate compartments without mixing. Smart solution, but open any one of those compartments and it's still a cylinder inside. The workaround is round two. That shape on the highway is not habit. It's not tradition. It's not aesthetic. It is the last shape standing after centuries of corners, cracking flat walls, failing, and boilers taking people with them when they went. And it has been running your daily life from your morning coffee thermos to the battery in your remote to the pressurized cabin of your last flight the entire time. If there's something you walk past every day and wonder about, drop it in the comments. We read every single one, and the best suggestions make it into future videos. Don't forget to subscribe so you don't miss what's coming next.